I'm going to try to do this with you today. Prove triangles congruent again, but not doing statements reasons. Rigid motions. Something that does not change the size or the shape. We've gone over 3 of them so far with you this unit. 3 rigid motions. Let's remind us what those 3 are. So just give me one of them right now. 2. Any of the 3 rigid motions we've discussed. Reflection is one of them. Yep. And this is going to go off. So. Yep. There we go. Let's get this back up. And I know this is not in your notes. I just wanted to review it with you. Okay, let's try this again. So number 1, yep, rigid reflections. Does not change size or shape. Real quick question though, what do reflections change? What do we call that term it changes? Orientation, the order of the vertices. Good, because I'm going to come back to that today. Another rigid motion which does not change size or shape. 15. Well, that's a type of reflection. I'm looking for another transformation. We've talked about 3 of them this unit, which do not change size or shape. Rotation does not change size or shape. And the final one we have discussed in this unit that does not change size or shape. 5, translation. Everybody good? Okay, translations. Now, here's what we're going to do today. We're going to do a translation, maybe followed by a rotation. Are those 2 figures still congruent? Yeah, because they don't change size or shape. All right, so that's what we're going to be doing. And I know this is very elementary schoolish, but through a lot of your questions today, you're going to see blanks, like fill in the blanks. I'm trying to have you guys write specifically what I'm looking for in the order I want it. All right, and that's going to be the same if we do happen to take the Regents in June, how to write these type of problems on the Regents exam correctly. So read through number 1 real quick. Read through number 1, what we're doing. So what's the transformation being performed here? What are we doing on triangle ABC? What's the transformation being performed on triangle ABC? 19. A reflection. Hey guys, does reflection change size or shape? So doesn't it make sense that ABC and A prime, B prime, C prime should be congruent if all I did was a reflection? Does that concept make sense before we write it down? All right, so what do I want written down? First, you tell me what you did. We did reflections. Reflections are, what do we call reflections? They fall under what category, eh? Rigid motion. So here we go. Reflections are rigid motions. And now you're going to give me a little tip on what are rigid motions. That preserve distance. When we say the word distance, we're basically talking about side length. Distance and sides are the same, and so are what? The sides and the angles. Good. Distance and angle measure. And then we can use a therefore, in conclusion, whatever you want. Triangle ABC. I know it's been a while, but congruent to the prime version. So that's what we're doing today. Hey, figure out what you're doing, and then you're going to say, oh, those result in congruent figures at the end. So reflections are rigid motions, preserved. And this is the exact same wording I want every time. All right, make it easy on you. Here's the tough part today. Toughest part. Everyone can just memorize what to write. Here's the toughest part. You find out what we actually did. All right. On number 1, I told you we reflected. On number 2, I'm not telling you anything. That's on you and your group to try to figure out what you did. All right. So did you rotate, reflect, translate? Let me give you a couple tips here. Okay, a couple things before I let you go, because I'm not going to do this for you. Absolutely not. Everyone see the triangles written out. Point A has to land on where? Where does point A have to land on? X. And where's B have to land on? Y. So whatever you tell me to do, A and X have to match up. B and Y and C and Z have to match up. All right. Next thing I want you to take a look at is the order of the vertices. Go A, B, C right now. What's the order of the vertices from A to B to C back to A? What's this? This is going clockwise. All right, everyone do X, Y, Z. X, Y, Z is what? Clockwise. Why am I asking you guys to do this? Did the orientation change? No, so you could probably rule out a reflection happen because the order of the vertices didn't change. This is going to be the toughest part today, and this is the part I'm going to spend the most time on. You figure out, what did I do to go from ABC to XYZ? Discuss it in your group, figure it out on your own, whatever you prefer. All right, what did I do to go from ABC to XYZ? And you better, A, better go to X. B, better go to Y when I do your rule. All right, so that's on you guys right now. Go ahead and figure out what the heck did I just do. And it better work on all the points. And we already ruled out it. There's no reflection involved. Okay, did we find out what we need to do here? To go from ABC to XYZ. Now, and I didn't say this before I let you go, but take a look here, guys. Doesn't it look like I got to turn this thing? Sliding it isn't going to do it. Absolutely not. Just sliding it. Everyone agrees it's got to be a turn. And a turn through how many quadrants? 1, 2, or even if you went this way, 1, 2. So at least a turn, a rotation. And if you go through 2 quadrants, how many degrees is that turn? 180. All right. So I don't know if some of you just said the transformation is a rotation. That's not good enough anymore. You got to get specific. Okay. So having the word rotation isn't going to cut it. I need to know the amount of degrees. So a rotation of 180 degrees. That's what it ended up being. That doesn't make any sense grammar-wise. So rotational 180. All right, here we go. Now everything becomes the same. Since, what did we just do? Rotations are rigid motions. They preserve distance and angle measure. I used therefore before, thus here, whatever floats your boat. Triangle ABC is congruent to triangle XYZ. Hey, that's going to be the toughest part. Hey, right here. There's the toughest part today. What the heck did you do? Okay, what did you do? Any questions here yet? Okay, let's pick it up a notch now. Directions. Little tip here. After a sequence of transformations, I am telling you, by writing that in the directions, you got to figure out this by doing 2 or more transformations. All right, when you see a sequence of transformations, you're not going to be able to do it in 1, so don't try it. It's going to have to be 2. This followed by this. All right, this followed by this. Real quick, take a look at the order of the vertices. ABC, what direction we going, guys? ABC. This is clockwise. What about ABC on your finisher here? Oh, so one of these two is probably going to be a what? A reflection over a line. Right away, you can tell that just by looking at the order of the vertices. Oh, I definitely did a reflection either at the beginning or at the end. And it also looks like maybe, well, I'll let you guys decide. All right. So get A to A prime, B to B prime. This is the toughest one right here. It's almost like a guess and check. Remember, a reflection's got to happen because the order of the vertices change. This is the toughest part. It's almost like a, so reflect over something right now and try to move it onto A prime after and see if it works for B. At least test it on two of the points. Toughest one right here. It's like a guess and check. But at least I know I got to reflect.
I know you would take that figure.
How we doing figuring out what we need to do? I think this is the toughest part. I don't blame you if you start struggling, but I can't tell you any other way other than it's a guess and check. Other than how you can tell if a reflection's involved. And I guess you could definitely tell if a turn was involved too, but think you got something here for me? All right, talk to me. What'd you do? Here we go. 7. What'd you do first?
I did a reflection of ABC over x equals 0.
So AKA the y-axis?
Yeah.
Okay, so we reflected over the y-axis. Everyone agrees there? A reflection over the y-axis. And then that would have got us not onto the triangle. I would need to do something else. What's the other one involved? 9?
Translation.
Of what?
Of 0, -3.
Down 3. Yep. Okay, so let's write it out here. ABC undergoes a reflection in the y-axis. Or you could write the symbol R with the lower subscript. And a translation down 3, or write whatever, write it in vector notation. If you want to write this instead, 0, -3. If you want to write the big T with 0, -3 below, all means the same. And you could have these flipped too. You could write the translation first, followed by the reflection. That's fine. Since reflections, and here we go, the usual. Since reflections and translations are both rigid motions, they preserve distance and angle measure. Thus, triangle ABC congruent to A prime, B prime, C prime. All good? All right, last one, and then you're on your own. All All right, this one I'm telling you what to do. All right, so first thing, everyone, here we go. Graph and label the double prime one, which is the image after a translation, 5 units right, 2 up, go. 5 units right, 2 up, graph it. That's going to be A prime, B prime, C prime. Translation, 5 units to the right and 2 units up. All right, now I picked this problem in particular because now we got to do a reflection over that line right there. We've done this a ton, I've just never called it that line that way. All right, review with me. Y equals any number, what type of line? Y equals any number is always horizontal. Now this is just horizontal going through 0. Look at your graph. Give me another name for a horizontal line that goes through 0. What's another name for it? The x-axis. That's just a fancy way of saying reflected over the x-axis now. Y equals 0. All right, go ahead and do so and name it double prime. What am I doing here? How about you flip it over the x-axis? And it doesn't say to state, right? Nope. Oh, graph and label. I don't need to do a double prime. All right, explain why they're congruent now. Oh, sorry, I dropped the blanks. You're on your own. Blanks will never be there when it's game time. So, all right, what did we do? Start by describing what we did. Triangle ABC was, what did you just do to it? What did we just do? You don't even have to guess here, guys. You know what you did. It was in the directions. Was translated. I'll even just put it in vector notation to shorten this. Right 5, 2 up, and reflected through the y line, y equals 0. Or write it out in words. I don't care. It's fine. That's why I give you guys symbols. Now tell me something. Translations and reflections are rigid motions. Which preserve, nothing's changing from the blanks, distance and angle measure. Anybody got a fancy word they want to plug in here? Thus, therefore, hence, henceforth, ergo. Anybody ever heard of that one? That's old school. In conclusion, as a result, somebody said in my one of my other classes a couple days ago when I did this, let's wrap it up, comma, whatever you'd like to put there, whatever fancy word you'd like to put there. Thus, triangle ABC congruent to triangle A double prime, B double prime. ABC double. And still giving you half the class to start the assignment. Come on, let's do this. Toughest part, do not give up. The toughest part's going to be figuring out how to move the triangles on top of each other. Don't give up on me. Let's go. Don't give up. Look at the order of the vertices first.